54 is a normal looking problem. Said it has a circle, kind of a semicircle problem at the front. You got it?
Yes.
When I assigned this probably didn't make a lot of sense, but after yesterday, maybe a little more. So let's verify that what we did yesterday made a little sense. Give me a way to think about G or describe G. G is what? This is set 54, sorry. Yeah, I taught you so poorly, you do not remember anything.
I don't think it's like you're teaching them like that. I think it's us.
Oh, no. The whole class is clueless.
I think it's just a movie day and we're trying to set our minds to.
Or is the problem the old, oh, I know how to do the problem, I just don't know what it's called.
This is called. Are you familiar with the question?
I want to know, how could you describe G? G is a function that accumulates area. G is an area accumulation function or an integral defining function. It's important that you know the vocabulary, so when I say, hey, it's an integral defining function, you know what the heck I'm talking about. So, G is a function that accumulates area from 0 up to some point, whether it be here, here, or here. The greater the x is, the more area that's accumulated. G at 6 then. When I say G at 6, and it's the same as the integral from 0 to 6, do I actually write equations and integrate the equations, or do I do the area some other way? Geometrically, this is a fourth of a circle plus a triangle. So did you get 9 pi over 4 plus 9 halves for G of 6? 10 4, good buddies. G prime. G prime would mean I take the derivative of this side, which means I take the derivative of this side. What's the derivative of the antiderivative? The derivative of the antiderivative is the function. So G prime of 0 is equivalent to f of 0. F of 0, do I look at the slope of the graph at 0 or just the graph at 0? Graph at 0 has a value of 3. G double at 0 then, I mean, really G and F are kind of one level off in terms of calculus derivatives, right? They're one level separated. So G double is equivalent to F prime. F prime, does that mean read the graph for the point, the slope, or the concavity? What do I do? The slope at 0. What's the slope at 0? 0 or undefined? 0. Horizontal slope is 0. It's not undefined. A number of people in math class said undefined. Undefined is vertical slope, not horizontal slope. Horizontal slope is just straight up 0. How'd those go? Bene?
Yes.
Bene. Bene, molto bene. Did we start about, you asked about this yesterday, but I can't remember how much we got through. We were doing the announcements. Got to see? Okay. So you might not have any problem interpreting what R is, but it helps me in such a problem where they give you a rate of change. R is changing at a rate of R people per year. Really, R then is a rate of change, so you could think of it as a derivative. It's not notated as a derivative, but isn't it like change in population with time? So in essence, you could think of R as P prime. It's the rate of change for the population. If you do so, it might be a little easier to interpret this, at least it was in the last class. If R is the same as P prime, then by fundamental theorem I take the antiderivative. What's the antiderivative of P prime? P at 3 minus P at 0. That then picks up another fourth of the people. This, kind of weird. This, getting there. But this, I can look at that and know what that's going on. That's change in population from 2000 to 2003. When you find that, it's, please, especially on the AP exam, don't round unless they say so, or at the very least give 3 decimals, then round. So negative 67.082 is my answer to the integral. You may use a calculator. Therefore, that means, in terms of the problem, what happened? Okay, so from 2000 to 2003, can I say 67 people left? You went too far. Why not? Why not left? May have died. Okay. What if 10 came and 167 left? Then what's the change in number of people? Decrease of 67, right? So you don't know how the change went. All that you know is that the number of people decreased by 67. You don't know 67 left. You don't know 67 died. That's reading way too much. All you know is the number of people decreased by 67. The population decreased by 67. Roughly 67 people. Okay? Find the population in 2003 using the fundamental theorem of calculus. Fundamental theorem of calculus, you should think definite integral. In real life problems like this, you should think of this as R, integrating R, which, again, I'm thinking of R as a rate of change in the population. So I'm going to think it in my mind as P prime. That's P at one point minus P at another. So now we need to determine what the points are. What are the two time components we want to look at? What's one of them? The most logical one we definitely need to consider 2003, because that's the question. What's the other question, the other time we need to consider?
Your initial condition.
The initial condition. Okay, so you said that well. It's logical to say 2000, right? Because time is since 2000. Why not 2000? Yeah, they don't give it to you. It'd be most logical to give you 2000, but I was trying to throw you a little monkey wrench in there. They actually give you population in 2005. So you need to refer what you want and what you have. And so we're going to go from 3 to 5. So when you integrate, it would be P at 5, the upper, minus P at 3. If I then solve for P3, or the population at 2003, I like to think of it as this going here and this switching back. So it's population 5 minus the integral from 3 to 5. That makes sense. I have a later point, so I'm going to take that population that was later and take away the change that happened to get the time and how much I had earlier before the change happened. So that in your calculator is something like 1,000. Again, report 3, and if you want to round to 2, to round to the nearest whole, you can. I got 1,183.689, so roughly the population in 2005 was 1,184 people. Did you get that?
Is it okay to have found the initial population and then added
Yeah, it's more work than necessary, but sure, go for it. That makes sense to me, I guess that's logical. Yeah. Okay? All right, are there any other questions on 54 besides those two extra practice? 25. 54.25 is x and y are two positive numbers. They tell you x plus y is 20. Find the values for x and y, xy is as large as possible. What kind of problem is this called? Let's keep shooting for that vocabulary, shall we? Greatest possible xy. We're trying to optimize. Yay! We're trying to maximize xy. I first of all was cooped out because that's not even an equation. That's just an expression. So I called it product xy. Product is xy. Should I start a maximizing and look for p prime positive to negative, or something else first? Yeah, you want to substitute in first, so y is 20 minus x or vice versa. Do that first so you can get it down to two variables. Tell me, how could you find the maximum here without calculus, with pre-calculus? What kind of graph is that? Parabola with zeros at 0 and 20. So where's the max? 10. So you could do this without calculus. With calculus, you'd see it all would be the same. 20 minus 2x is 0 at x equals 10. And it is going positive to negative at that point. But that's the idea. And then make sure you answer the question. Find the values of x and y. So x and y would have to be both 10. Usually the most equitable distribution is the most efficient distribution. Okay. Any other questions on 54? 54, extra practice. Here we go. We did the first part together, then you started doing stuff on your own on the table part, on the back of that gold sheet. Really? So, the idea was to reinforce the ideas of integrals, where remember this is displacement, this is distance, and if velocity is positive, then this is both. Okay, so keep that in mind. Another AP pointer for you. You should do the problem in the order in which it's asked. Too many people will lose points on AP exams because they interpret the answer when that wasn't the question. It was explain the meaning of the integral, not your answer. And those are graded differently. If you're asked to interpret your answer, then your answer is in your explanation. But if you're asked to interpret the expression, then you should be doing that first and then finding the answer. So what is this? What does this mean? Am I finding distance or displacement? Displacement. You could say this, the integral represents the displacement, or you could also say change in position, which is what displacement is, I suppose. Now, again, being careful. Units. It says using correct units. So, displacement in meters from, and then your time interval, from time 0 seconds to time equal 10 seconds. A grader would grade for 4 things. They'd say, do you say displacement? Do you give the distance units? Do you make a reference to the time frame? And do you give time units? That's 4 things you've got to check for that problem to get 1 point. All right. Estimate the value with the right Riemann sum. So you would say this is an approximation. In my mind, that's what I'm doing. But I probably don't write that on the AP exam. The base of the first time interval. If I had this graphed on the axis, then the first time interval base is 4 seconds. If you want to put units in there, that's fine. I tend to make mistakes with S's because they look like 5s, and I then treat it like a 5 later, so I don't put it in there. On the AP test, they don't require it. They do require you to show where your values are coming from before you go to the table. So, if I'm using a right Riemann sum, then in this time interval, I'll use V at 0 or 4. Hello? 4. Okay? Don't go to 7 yet. It's not time. The next time interval is 3 seconds times the speed for that, or velocity for that right end is 7 plus 3 seconds. V at 10. After that, you're ready to go to the table. 4 times 7 plus 3 times negative 4 plus 3 times 8 is 28 minus 12 plus 24. So 40 meters. At time equal 10, you could say the car is 40 meters forward of where it was at time 0. Okay, estimate the value of that bad boy. If you're integrating absolute value, then you're finding distance. It does say to estimate this first and explain the meaning of your answer, not the expression. So, how would this change? It would be a lot like this, except instead of every v, you'd have absolute value of v. So it would be 4 absolute value of v at 4, plus 3 absolute value of v at 7. Plus 3 absolute value of v at 10. And so this would be more like 28 plus 12 plus 24, or 64 meters. Notice here it doesn't ask you to explain first. It asks you to explain your answer. So tell me what happened. From time, or did you say what it did first and then the time, or the time first? What did you do? You could say either. The car travels approximately a distance of approximately 64 meters from time equals 0 seconds to time equal 10 seconds. Wait, yes?
Do you have to include, I'm sure you do, the 4 times the absolute value of 4?
You do.
You do? Okay.
You do. On the AP exam, they wouldn't have asked both of those questions. They would have asked one or the other, so it wouldn't be so redundant. I mean, I feel what you're saying, and you have to show all that stuff again, but yeah, you should. Because that's what you're doing.
Okay, no, what?
Sorry. So you are saying you have to show the absolute value?
Yeah, and you have to show the 4 times the negative 4 of that. Because I just went to the 4 times 7 plus 3 times negative 4. Like, I just went straight from that. I didn't show
Yeah. Yeah, if you don't show the V part of that, you'll almost always use it. You're welcome. Sorry, I didn't answer your question. Estimate the acceleration at time 2. The big idea, you don't necessarily have to write this, but the big idea of approximating a instantaneous rate of change, I guess I'll write it this way. A prime at 2 is dv dt at 2, and we approximate instantaneous change in velocity with time with an average rate of change. That said, then you could say something like A prime at 2 is approximately equal to. If you have hard equal, you will absolutely lose points. V at, what's the time frame that would tell me about how fast velocity is changing at 2? It's not A prime at 2, it's A at 2. Sorry, I was thinking V prime at 2. My bad. Sorry. A at 2 is approximately equal to change from 0 to 4. Are we? Don't say that. Okay, so the velocity changed by 2 meters per second in 4 seconds. So the overall average rate of change, which approximates the instantaneous rate of change, is 1/2 of a meter per second. 1 meter per second squared is 1/2. You follow? Okay, last but not least, a little fundamental theorem. You are given the position at time 10 is 5 meters. What is the position of the car at time 4 using a left Riemann sum? Left Riemann sum tells me you're approximating an integral of velocity, and the Riemann sum part I'll come to, but I'm not ready for that part yet. I need to kind of get established what the heck I'm doing. If I want to talk position, then don't I want to talk fundamental theorem? Integrating velocity is change in position over a time interval. What time interval should I make reference to or use? What 2 time points do I want to use? 10 and 4. Good, buddy. So that means that I will be finding change in position from time 10 to time 4, or from 4 to 10. If I then solve for what I want, x at 4 would be x at 10 minus the change in position. Now I'm about ready to approximate. X at 10 is 5. The integral is going to be approximated by a Riemann sum. Finally, I'm at the rectangle Riemann sum. How many subintervals from 4 to 10? 2, yeah. So I'm looking at 2 rectangles. The first is a time frame of 3 seconds, and I use v at 4 or v at 7 if it's a left Riemann sum. 4, all right, so 3 seconds times v at 4, plus the next subinterval is 3 seconds times v at the left edge, so v at 7. This then is 5 minus 3 times -4 and 8. So something like 5 minus -12 plus 24. 5 minus 12, negative.
It's supposed to be 7.
Yeah?
Or it is before 7.
Oh, I'm using the right hand, not the left hand. So 7 and 4 are these values?
So the -12, no.
7 and -4. Okay, so 5 minus 9, so -2 meters. How's that? Bene or not so bene? Bene, bene. Okay, let's go to the old graph problem, using a graph to work this idea. Anybody have any idea when we get out of here?
At the 6.
I'm sorry, what'd you say?
At the 6.
Are you trying to tick me off by saying that?
10:30.
At the 6?
It's 9:6, which gives us 9 minutes.
You go,
My sister-in-law teaches kindergarten, and they help me better than that.
At the 6? You look at the clock and you be like, at the 6. It's like, okay, great.
So
Well,
otherwise you're
You
on
might as well
the
follow
end.
that with at the 6, me moron.
just
something.
I know I
That is ridiculous. Are you kidding me?
Self-aware.
Unbelievable. At the 6. It's Armageddon. Okay. This, from 0 to 8, because there's no absolute values, that distance or displacement. It is. Actually, it says find the value first. Sorry. So what's the value? What's the value? The area under the curve. Keeping stuff negative, it is -5. That's the answer to the first question. Using correct units, explain the meaning of your answer. This is a particle moving along the number line. So you could say that, I don't know where the car started. Actually, I do know later. But it moved left for a while, then right for a while. It moved left 8 units and then right 3 units over the course of the problem. So, explain the meaning of your answer. You would say at time 8, the particle is 5 units left of where it was at time, that's seconds by the way. At time 0 seconds, you could say that. I suppose you could also say from time 0 to time 8, the displacement of the particle is 8 units to the left, or -8 units, something like that. Although I think this reads better. Okay. Explain the meaning of this guy. First it says explain the meaning, so that meaning is this is the distance or displacement? Distance. The particle travels units in units from time 0 seconds to time 8 seconds. The evaluation of that is it 5, negative 5, or 11? 11. Okay, absolute value takes care of the negative. Makes it positive, so it's 8 plus 3. Okay. What about the meaning of 4 to 8? It seems redundant at this point. Am I adding anything new? How is 4 to 8 different? It's distance and displacement. Okay. So velocity is greater than 0 on 4 to 8. So this is both the distance and the displacement. In units from time 0 seconds to time 4 seconds to time 8 seconds. Does not ask you to find it, although if I found it, it would be 3. Okay, then fundamental theorem problem. Given x at 4 is negative 7, find the position at time 8. To get x at 4, I'll probably want to integrate velocity. That will be change in position over a time interval. And I want to relate what I have to what I want. I know time 4. I want time 8. So I'm integrating 4 to 8. The difference would be change in position from time 8 to time 4. If I solve for time position at 8, it is position at time 4 plus the change. And that then is negative 7 plus, notice the hard equals. These are exact. These are approximations. 3. So, negative 4. Oh, that would be a good one. I should ask through that. Oh, no, we're not ready for that. Is acceleration at 4 positive, negative, or 0? Why? What does acceleration have to do with the velocity graph?
The slope.
It's the slope. The slope at 4. Positive or negative? Positive. Okay, so you'd say A at 4 is positive because the slope of the V graph is positive there. Okay. Velocity is increasing, in essence. You could also say because velocity is increasing at that point. How did this go? What did you get for an answer to this bad boy?
B.
B. I don't remember. Where's my key to this? I know I put a key to this. Do we all agree with B? How?
Oh no, it's just because I'm here.
No?
I didn't say stupid that time.
I started with acceleration and got velocity. Velocity is the antiderivative of acceleration. This is a little different because it's using the initial conditions to find the c's. This is a hard part to get. You use an initial condition one of two ways. If they wanted velocity at an actual instant, then I could use the initial plus the change and do a definite integral fundamental theorem problem. That works just fine if you want it at a number. But if you want it all generally, what is the velocity of, then you have to find the plus c. So if I integrate 2t minus 6, then I get t squared minus 6t plus a first constant. To find that c1, I need a v and a t. They tell me that at time equal 1, velocity is 3. So if I plug that in, I get that constant must be 8. Yes? Okay. So the velocity is t squared minus 6t plus 8. Now the position. It's the antiderivative of velocity. Antiderivative of t squared minus 6t plus 8. It's 1/3 t cubed minus 3t squared plus 8t plus a new constant. You need a time and an x to put in. They say at time 1 the x is 1/3. So 1/3 is 1/3 minus 3 plus 8 plus C2. The 1/3 subtract away. C2 must be -5. You got your equation. It must be your threat. Okay, boom. How did this guy go? Pretty bendy or not so bendy? Bene, bene, molto bene. When is it changing direction from time 0 to time 10? C, because velocity changes sign. So crosses the x-axis, or the t-axis, I suppose. Okay, total distance. That is that. Yeah. Okay. Hey, maybe I could get this today. What do you think? Huh? No? Yeah. Sure. No. That's a no. Really? We're gonna go get told out. Really? No, that's a no.
And I had got something like this, and right here it was like this. And mine was like,
Really?
I guess it was like this. Like you just like,
Your dog eat your
Dog?
my guinea pig.
Oh.
That's really impressive.
No, really, Mr. Rickman?
That one, I don't know like which one is the both like
He was, but like also, I mean not. He's not a great singer, but he thought he could do it, and I knew he could. So it was something like that.
Yeah, that's
So,
He was
so it was
so
like
upset
I was
this
just-
morning. I was like, Sebastian, you could do Staker. He was like, no, because then I'd have to see all the actors. I'm like,
oh, he's just gonna quit.
yeah, I think he's just gonna quit.
Ellie,
Way-
have they started doing stage
Oh, yeah.
Yeah, they have.
You know when we had that first meeting?
No, I wasn't there
Okay,
because
well,
of
when we
marching
had that like
band.
very first meeting, because he was like, we're gonna do it on Saturdays, and we're doing it on Saturdays because so we're
Oh, I
gonna
can't,
do.
are you doing it this Saturday?
No.
I think in like both stages and.
Who should I text about that? Is Lizzie running?
Yeah, you could like make
Okay.
stuff and also do ensemble. I mean, I did that a little bit for play. It showed up to 3 days. So, yeah. It's just being, is he fit?
Half of our class is going to be at lunch. Because it depends on your which period. My 5th period I have English, so I'm in here.
We have a test today, right?
Are you still here? Thanks, Grace. Ricky, do you know if we're first or second lunch?
If you,
Grades on the fifth period.
you have second lunch. You after.
It's tech, the last time we went up.
Oh, yeah, you
there,
get
just
to
period, and he's like,
You just need to talk to guys. You just need to talk to me.
have you seen him?
Yes, I see that. I just haven't talked to her.
He's like, he's scary.
He's like this. Scary.
He has me, Bruce. Hey, Grace. You're back to Grace.
Tell my Sarah.
He's scary though.
Stretch. I didn't know. Don't stretch. Stretch.
Yes, no.
Yes.
Why is it?
Oh, shoot.
It's called the doctor.
I was recording this the whole time. Dumb.